What is the RCC-F and why a fire code? The RCC-F provides the design and construction rules for the fire protection of pressurized water nuclear power plants. The fire is the subject of important regulation for the protection of personnel, concerning the provision for alarm, evacuation and access of firefighters, as well as certain principles of fire spread limitation. In addition, stricter rules are required to control the effects on nuclear safety and direct impacts on the environment. Indeed, among the internal hazards originating within the facility, fire has the highest probability of occurrence. The specificity of the fire risk is that the development of an outbreak of fire is closely linked to the configuration of the facility, and that its effects depend on this development. On all these aspects, the RCC-F code proposes a global design approach for controlling the fire risk in the installation. What part of the plant does the RCC-F apply to? It applies in the first place to the buildings of the nuclear facility involved in the nuclear safety functions, or the containment of radioactivity. By extension, it applies to buildings involved in nuclear safety scenario, for example, the loss of external power supply involving the turbine hull. How is this code being developed? The code is developed by the AFSEN RCCF subcommittee. It benefits from the sharing of know-how and feedback from designers, operators, laboratories and suppliers in the nuclear field in France. There are also connections with partners from other countries, including a Chinese mirror committee. Who is the RCC-F made for? The RCC-F code is intended for engineers involved in the design of nuclear power plant, design of buildings and facilities, fault studies and safety report, specification of fire protection equipment and systems. It is indirectly meant for suppliers of fire protection equipment and laboratories in charge of qualification tests. Finally, it provides the nuclear safety authorities with the guarantee of a coherent global approach and standardized and proven solutions. How is the RCC-F structured? The RCC-F is divided into 5 volumes. Volume A is devoted to generalities, definitions and quality assurance. Volume B constitutes a guide dedicated to safety principles according to a classic approach, consistent with the main high-level international regulation and guidelines, IAEA, WENRA, WANO, etc. Volume C to D describe a process for dealing with fire hazard based on the safety principles presented in Volume B. Each project implementing the RCC-F code remains in control of its safety principles and can adjust its rules while maintaining the Volume C to D process. Volume C of the RCC-F discusses the principles of protection based on defense in death, prevention, detection and control, mitigation of consequences based on 2 principles. Zoning of the building, which allows the fire to be contained within fire volumes. Treatment of residual common mode failures in each fire volume by detailed fire risk analysis and functional analysis. Annex G of the RCC-F code develops best practices in terms of study methodology. Volume D of the RCC-F describes the building design basis. It includes in particular aspects related to personal protections, escape routes, stairs, signage, alarms, etc. This volume also develops the principles of ventilation specific to fire, smoke extraction or control, by resolving potential conflicts between regulatory requirements and nuclear safety constraints, in particular the containment of radioactivity. Volume E of the RCC-F draws up the rules for the design and installation of plant equipment in connection with fire protection. For fire equipment, the code details the qualification requirement, for example, fire resistance of fire barriers, and implementation, taking into account the combination of hazards specific to the nuclear safety demonstration. Detection, extinguishing system and the fire water network, Fire barriers such as penetration seals, doors, valves, floor drains, etc. are discussed in this volume. For other equipment and components of the facility, the code specifies layout principles and reaction to fire in order to reduce fire risk upstream. Ventilation, filtration and cabling are discussed in this volume. How is this regulation approached? The fire regulations are very much country dependent. As such, the RCC-F proposes an internationally compatible set of requirements in the body of the text. Parts in the text that may be affected by national regulatory requirements are identified, and detailed regulatory annexes are provided for 2 countries, France and the United Kingdom. In conclusion, the RCC-F provides the key requirements for a consistent and comprehensive design of fire protection for pressurized water nuclear reactors. It enables an efficient demonstration of safety based on updated and standardized methods, benefiting from experienced feedback from the nuclear industry. AFCEN provides certified trainings for users of the RCC-F code.